next example is finding second order derivative. X to the power 4 plus y to the power 4 equals 16. Again, this equation represents y as a function of x. Y is a function of x. And the question is, find the second order derivative of this function. So how can we do that? Well, first we find the first order derivative, which is y prime, using the same method, using left hand side derivative equals right hand side derivative. So find y prime by left hand side derivative equals right hand side derivative. So right hand side is a number, therefore the derivative of that is 0, so right hand side derivative is just 0. But the left hand side is this expression x to the power 4 plus y to the power 4, so the derivative of that will be x to the fourth derivative is 4x cubed plus, and then derivative of y to the fourth is 4y cubed, and again, whenever we do derivative of anything involving y, we need to multiply times y prime. So that's the derivative of the left hand side, and that equals the derivative of the right hand side, which is 0, so that equals 0. So now we need to solve for y prime, and this is easy. We take this term that has no y prime in it to the right hand side of the equation. So it becomes 4y to the fourth y prime equals negative 4x, 4y cubed y prime equals negative 4x cubed. And then y prime equals negative 4x cubed divided by 4y cubed. Of course we can cancel the 4 and we get negative x cubed over y cubed. So that's the expression for the derivative. Now we need to find second order derivative. Actually there are several ways to proceed. One way would be to take the formula for the first order derivative and then just apply the quotient rule to it. But I want to show you a different method. So the other method I want to show you is this. We take the same equation and now we do left hand side second order derivative equals right hand side second order derivative. So the method is left hand side second order derivative equals right hand side second order derivative. And again, since right hand side derivative is 0, then of course second order derivative is also 0. And for the left hand side second order derivative, well, we need to take the left hand side derivative and now apply one more derivative to that. So left hand side second order derivative is this. 4x cubed second order derivative, which means one more derivative, it will be 12x squared plus, and now 4y cubed y prime, since there is a product here, we've got to use the product rule. So, product rule, and the product rule goes derivative of the first term times the second term plus the first term times the derivative of the second term. So, the derivative of the first term, and the first term is 4y cubed, derivative of that will be 12y squared and then times y prime. So let me write it like this. 12y squared y prime, that's derivative of the first term, and then times the second term, which is another y prime, plus, now the first term, which is 4y cubed, times, and then we need derivative of the second term. But since the second term is y prime, so derivative of that will be y double prime, the second order derivative. and that is equal to the second order derivative of the right hand side, which is 0. So in other words, if we simplify it all, it will be 12x squared plus 12y squared times, and now it's a y prime times another y prime, so it's a y prime squared, and plus 4 y cubed y double prime equals 0. So our job is to just to solve it for y double prime. One thing we can do is actually divide everything over 4 just to make the equation a little simpler. So 12 becomes 3 and 4 becomes 1. So it's a 3x squared plus 3y squared times y prime squared and plus y cubed y double prime. So now we want to isolate y double prime. For that we could actually put this term into the other side of the equation, the right hand side, so it becomes negative. So 3x squared plus 3y squared times y prime squared equals negative y cubed y double prime. Now to isolate y prime we need to divide over negative y cubed. So it becomes y double prime equals negative all of this divided y cubed. So 3x squared plus 3y squared times y prime squared, and all of that divided by y cubed. So it's almost done, except we need to replace this y prime with whatever it equals in terms of x and y. And we know what it equals in terms of x and y, it equals this. So basically we need to plug in this term into here, and since it is squared, then this minus will go away. Minus squared is plus, so we need to square this, so it will be x to the power 6 over y to the power 6. So it will end up y double prime equals negative 3x squared plus 3y squared times, and now y prime squared becomes x to the power 6 divided y to the power 6. When you x cubed squared is x to the 6, y cubed squared is y to the 6 divided by y cubed. Now we can cancel y squared, like y squared, and here we can make it y to the power 4. And the final formula is y double prime equals negative. So here we have 3x squared plus, here we can write 3x to the power 6 over y to the power 4, all of that divided by y cubed. So this is the answer. If you wish, you can simplify this answer even further, maybe by bringing the common denominator and taking the y to the fourth to the bottom, but actually this is the answer. So this is how to find second order derivative of an implicitly given function.